This project involves 3 different neural networks into an application for human-machine collaboration with a collaborative robot. These 3 neural networks, alongside with a webcam, a microphone, and a 3D camera, achieve a great interaction between the human and user when the user requires to have the least intervention possible in the robot's activities. In addition, it achieves a greater flexibility in all these tasks.
During the training of the networks, a wide dataset with different conditions and users was used. The project integration was carried out through a series of nodes running in Rust, which, along with additional robot programming, allow us to move the robot and have a dynamic and versatile workspace.
The project is made up of different systems that work together. The first of these systems allows us through a microphone and a neural network to classify the voice commands that the user gives to the robot in order to control it. The following system allows us to move the robot's end effector to a position close to the user's hand. This through a camera and a neural network that tracks the position of the hands. This allows us to deliver and receive parts by the user seamlessly.
On this side is the object identification system, which uses a camera and artificial intelligence to identify the different elements that make up our assembly of our application, so that the user does not have to tell the system what piece is being delivered, but so that the system can know by itself what piece is being delivered and thus to store it in its respective place, thanks to a marker which serves the system to map the positions of the pieces.
In general, the system has 2 routines: bring and take. Further on, we will give you a demonstration of each one of them.
Waiting for take of bring command.
Bring.
Bring routine.
5.
I will go for part 5. Say go to open the gripper.
Go.
Waiting for take of bring command.
Take.
Take routine. Say go to close the gripper.
Go.
Part 5 detected. I will store it.
Through the integration of various neural networks, a seamless human-robot collaboration is achieved. These systems can be employed in different industries involving manufacturing and medical assistance for carrying out assembly and human-robot collaborative tasks.